Unlike some other popular programming languages, Python lets you define classes that can inherit from more than one base class. This is called multiple inheritance. And while it can be a useful tool, it can also cause a lot of problems if you don't use it carefully. So let's open up the multiple_start file and see how it works. So here in my code, I have two classes, class A and class B, each of which define an attribute. So in class A, we have foo, and in class B, we have bar. Then I have a third class named class C, which lists both class A and class B as base classes separated by a comma. And this is how you inherit from more than one class at the same time. So let's go ahead and add a method to class C to print out those attributes. So I'm going to call the method showProps. And I'm going to print out self.foo. And then I'm going to print out self.bar, each of which is inherited. And then let's call that method after the C object is created. All right, so let's go ahead and run this code. And in the output, you can see that the two properties are being printed, right? So there's foo and there's bar. So everything seems fine. But what happens when each of the two superclasses define the same attribute? So let's go ahead and add an attribute to each one. Let's have self.name equals class A. And then let's have self.name in B equal to class B. And now let's print this out in the showProps method. So now I'll print out self.name. So now let's run the code again. So we'll save and we'll run. And now we see foo bar and okay, I guess class A is somehow the winner. But why is that? So when you call a method or access an attribute in Python, the Python interpreter uses something called the method resolution order to look it up in the class. So the lookup starts in the current class, in this case, class C, which doesn't define the name attribute. So then Python looks in the superclasses in the order in which they are defined, from left to right. So since class A is listed first, that's why we're seeing the class A string in the output. So if I change the order to be B and then A, and then I'll save and I'll run the code again. And so now you can see that the function prints out class B because that's the one that's being looked up first because it comes first in the order. Now, it turns out that you can actually inspect the method resolution order by looking at a special class attribute called MRO. So let's go ahead and add that. I'm going to print the C classes __MRO attribute. And now when I run this, you can see that the method resolution order is first it's class C, right? Then it's class B because that comes first in the order. Then class A because that's next. And then the object class, which is the implicit superclass for all objects in Python. So this added complexity is one of the main reasons why you don't see a whole lot of multiple inheritance in real-world projects, but there is a place where they actually are very useful, and that is in implementing a programming construct called an interface. And we'll see how that works in the next video.